Hello everyone. My name is Sambayeva Adiya, and today we're going to revise IB Chemistry, Unit 4. It's also called Chemical Bondings. So, let's start with ionic bonding, and I think we should start with definition. An ionic bond is due to electrostatic attraction between oppositely charged ions. The definition is pretty simple, however, you have to know the keywords like electrostatic attraction because without them, you'll not be able to properly write the definition and explanation on your IB exam. And you also have to know these keywords for other definitions of bondings. We'll cover them a little bit later. Second, ions are formed when one or more electrons are transferred from one atom to another. I think you already knew that from MYP. The number of electrons lost or gained is determined by the electron configuration of the atom. We covered electron configuration in the third unit. The reason there is transfer of electrons is because they want to achieve a noble gas configuration. This thing is also called octet rule. You might know this knowledge by this definition. Next, positive ions, cations, formed by metals losing valence electrons. Negative ions, anions, formed by non-metals gaining electrons. This is already, I think, the knowledge you might already know. And the short form, how to remember this, or mnemonic for this information is OIL-RIG. Oxidation is loss of electrons, reduction is gain of electrons. And the last one, ionic compounds are typically solids and have lattice-type structures that consist of 3D repeating units of positive and negative ions. We'll cover lattice type like more deeply in HL part, if I'm not mistaken, but maybe in SL too. Next are physical properties, and the first one is volatility, or the ability to vaporize. Here's definition: tendency to vaporize. Ionic compounds have strong electrostatic forces that they have low volatility. Second one, electrical conductivity. For ionic compound in solid state, ions occupy a fixed position. Hence, they do not move around or conduct electricity. In molten state, they are free to do so. And solubility. Ionic compounds dissolve in polar solvents such as water. This is because partial charges of polar solvents are attracted to ions in the lattice. So basically, when ionic compound is in molten state and in water, water molecules surround, for example, let's say positive ion, because water is polar itself. So oxygen is slightly more negative, while hydrogens are slightly more positive. So, for example, if we take into account positive ion, it's going to be surrounded by oxygen, while hydrogens will surround negative ions. And here, as a result, individual ions are pulled out of lattice structure. So basically it was short information about ionic bonding for you to revise. And second one is covalent bonding, and here is also its definition: formed by electrostatic attraction between a shared pair of electrons and the positive nuclei. Here, as you can see, we also use these keywords: electrostatic attraction, again. In ionic, atoms lose or gain electrons. In covalent, atoms share electrons to achieve noble gas configuration. It occurs between non-metals. There are single bonds double bonds, single bonds like with fluorine, double bonds with oxygen, and triple bonds with nitrogen. There is also hydrogen fluoride, for example, in which a hydrogen does not acquire an octet rule. Then there are some tendencies that you have to know in covalent bondings. They are bond strengths and bond lengths, and here you can see them. The trend in bond strengths is triple bond has a higher strength than double, and double has a higher than single. And the trend in bond lengths is that single bond is longer than double and double than triple. You have to know these tendencies because you'll have some questions in your papers, and they will not ask you the tendency itself, but you will have to know to understand what they want from you. Next one, electronegativity. As you remember, we already covered electronegativity in third unit. Electronegativity is the relative attraction that an atom of an element has for the shared pair of electrons in covalent bond. It can be determined with electronegativity value, the type of bond. To find delta electronegativity, subtract the electronegativity values for two atoms. So basically here, to understand the type of bond, you have to subtract the electronegativity value of one atom from another or ion, and the given value will show you the type, like ionic, polar, covalent, or pure covalent. Next are intermolecular forces. There are three types of intermolecular forces of attraction. They are London forces. They are also called dispersion forces or London dispersion forces, or instantaneous induced dipole forces. This definition is like too long, so I think London forces is enough. The second one is dipole forces, and the third one is hydrogen bonding. And also you might see sometimes in other books or even on your exam van der Waals forces, and basically these forces were found the first, and they include London forces, dipole forces, and dipole induced dipole forces, so for your information. And I wanted also to say about intermolecular forces, its definition. So intermolecular force is a force that mediates interaction between molecules, including the electromagnetic forces of attraction or repulsion, which act between atoms and other types of neighboring particles. So it's basically force that mediates attraction between molecules. And here, let's see London forces. And for this example, let's take hydrogen bond. Hydrogen bond, for example, all the molecules is non-polar. Every hydrogen molecule consists of positive nuclei with cloud of negatively charged electrons. If you were to take a snapshot at any given instant of time, one part of molecule may have slightly more electron density than another part. This generates a temporary dipole, is termed an instantaneous dipole. So temporary means not permanent, not for a long time. And what affects magnitude of London forces? The first one is number of electrons. So greater the number of electrons, the larger the distance between the valence electrons and the nucleus. And and this is why the attraction of valence electrons to nucleus will be reduced. The second one is size, or volume of electron cloud. In a large electron cloud, the attraction of electrons to the nucleus will not be as great as in smaller clouds. Hence, the electrons in larger clouds can be polarized, easily increasing boiling point. And the last one, shapes of molecules. Larger the surface area of molecule, the more area of interaction with other molecules, increasing the boiling point. Here, dipole-dipole forces exists in all polar molecules permanently when positive end of one dipole is attracted to negative end of one dipole. And hydrogen bonding, this is what I was talking about before about water, occurs only between hydrogen and fluorine, oxygen, and nitrogen. Occurs between molecules. Examples include hydrogen bonding in water. So don't forget about fluorine, oxygen, and nitrogen, because these are the only elements hydrogen creates bonds with, hydrogen bonds. And as you might see on the picture on the right side, you can see water molecules, and as you might understand, water molecules are both dipole-dipole and hydrogen bonding. And here you can see on the bottom the strengths of every bond, and London forces are considered the most weak. Next, dipole-dipole forces, and then hydrogen bonds. So let's move. Then metallic bonding. Metals have low ionization energies, so valence electrons can be delocalized throughout metal. Structure of metal is a giant lattice of positive ions, cations, surrounded by a sea of delocalized electrons. So here it's a little bit confusing. So for example, in covalent there is like a structures, lattice structure, but here we don't really have the same thing. It's more of like cloud around positively charged ions, cloud of electrons. And this is the reason why metals are good conductors. Metallic bond, here's definition: the electrostatic attraction between a lattice of positive ions and the localized electrons. So there is lattice between positive ions, but electrons are moving more freely. Strength of metallic bond depends on number of valence electrons that can become delocalized. So the more electrons, the more valence electrons, the more they can create the cloud. Second one, the charge of the metal ion, because charge shows the ability to attract valence electrons. Third one, the ionic radius of the metallic positive ion. Basically these three. Next, alloys. Alloys is a mixture that consists either of two or more metals, as you usually see, metals combined with an alloying element, one or more non-metals. Alloys have enhanced properties such as strength, hardness, and durability. For example, the gold that we use in jewelry is not actually the pure gold, because pure gold is not that, it has like low strength, it's not that hard, and it can change its form easily, so people are mixing it with other metals to make it more hard. Next, electrical conductivity. This is what I was talking before. Metals are good conductors because the delocalized electrons can move through the metallic structure and carry a current. Presence of impurities can restrict movement. Next, malleability. Metals are malleable because cations can slide past each other, which leads to rearrangement of solid. Non-directional bonding. Trends in melting points. Melting points depends on the strength of the attractive forces that hold the delocalized electron together. So basically, this is all about metallic bonding and about Unit 4 in general. Thank you for your attention. Goodbye.